So the last topic of today's lecture are linear equations. Now, the simplest form of a linear equation is the equation ax equals b, where a and b are known constants. And we have to solve for x. Now this is quite easy because we divide both sides of the equation by a, and what we get is that x equals b over a. An example with numbers is, for instance, 2x equals 5, and then we get x equals 5 over 2, because we have to divide both sides of the equation by 5. A slightly more complicated variant is when we consider the equation 2x minus 3 equals 5. Then we first have to take minus 3 to the right hand side. And so we get the equation 2x equals 5 plus 3 is 8. And then we divide both sides of the equation by the coefficient of x, which is 2. And we get x equals 8 over 2 is 4. Now why is this equation called linear? Is because x only occurs at one place, and it occurs as x and not as x squared or any other function of x. So what we are really interested is to solve a system of two linear equations with two variables, x and y. Now, the easiest way to study such a system is by an example. So, suppose that we have the following set of equations: 3x plus y equals 6, and 2x plus 2y equals 2. Now, the idea for solving such a system is by eliminating one of the variables and then solving for the other one. So the first thing to do is select a variable that we want to eliminate. Say we take x. Okay, what we do then is look at the coefficients of x in these equations, and what you want to do is multiply both equations by some factor in such a way that they get that the factors of that the coefficients of x become equal. What can we do in this case? Well, for instance, we can multiply the first equation by 2, the coefficient of x in the second one, and the second equation we can multiply by 3, which is the coefficient of x in the first one. And if we do this, then what do we get? We get, as the first equation, we get 2 times 3x equals 6, x plus 2 times y equals 2 times 6 equals 12. And the second equation is multiplied by 3, so we get 3 times 2x is 6x plus 3 times 2y is 6y equals 3 times 2 is 6. And now what we see is that x has the same coefficient in both equations. And the way to get rid of x is by subtracting these two. And then we get 0 times x, which cancels, plus 2y minus 6y is minus 4y, and this is equal to 12 minus 6 is 6. So we get an expression for y. We can solve this equation for y by dividing by the coefficient of y. So we get y equals 6 over minus 4 is minus 6 over 4, and we can cancel out the common factors, because 6 is 3 times 2 and 4 is 2 times 2, and we get minus 3 over 2. Now we know y, so we can plug this value of y into one of the equations. For instance, we plug y into the first equation. So we get 3x plus y equals 3x minus 3 over 2, and this must be equal to 6. So we get that 3x equals 6 plus 3 over 2 is 7.5, which is 15 over 2. And dividing both sides of the equation by 3, we get that x equals 15 over 2 divided by 3, which we saw before that this is the same as dividing 15 by the product of 2 and 3 is 6. And again we can simplify this expression by cancelling common factors in numerator and denominator, and so we get that x equals 5 over 2 is 2.5. So we get precisely one solution, and the solution is given by x equals 5 over 2 and y equals minus 3 over 2. And of course we can check whether this is the correct solution by inserting it into the two equations that we had. So we get 3 times 5 over 2 is 15 over 2, plus minus 3 over 2 is 12 over 2, which is equal to 6, which is indeed the correct answer. And the same we can do for the second equation. Now the question is, of course, do we always have one solution? Or can there some things happen which other things, no solutions, many solutions? Well, indeed, both of these things can occur. So what is the first situation that we now can consider where we do not have one solution? So to this end, we look at the following set of equations. Instead of 3x plus y, we write 3x plus 3y equals 6. And we keep the other equation as it was. Now, if you look at these two equations, then you see that the two left-hand sides differ a factor of 3 over 2. And the two right-hand sides differ a factor 3, 6 over 2. So this is not the same factor. So what we expect is that this system cannot have any solution. And indeed, when we use the same trick by multiplying the first equation by 2 and the second by 3, because we had the same coefficients of x as in our previous system, then what we get then is the following two equations. Well, multiplying the first equation by 2 gives us 6x plus 6y equals 12, and the second is 6x plus 6y equals 6. And when you subtract, you get 0 equals 12 minus 6 is 6. So clearly this is impossible, and so we have no solution at all. This is one case. The second problematic case is the following. We have the same left-hand side, 3x plus 3y equals something, and 2x plus 2y equals 2, but instead of 6 over here we take 3. And what you now see is that the same factor between the left-hand sides, 3 over 2, and the right-hand sides of these equations. And the first is 3 over 2 times the second. Now if you do the same trick by multiplying the first by 2 and the second by 3, we get the same right-hand sides over here, and so the answer will be 0 equals 0, which is true for every x and y which that satisfies one of these equations. So if you think a little bit, then you realize that all points x and y, all variables x and y, which are solution of 2x plus 2y equals 2, also solve the first equation, and so they are all solutions. Now it's quite easy to write down many of these solutions. For instance, 0, 1, x is 0, y is 1, x is 1, y is 0, x is 1 half, y is 1 half, etc. are all solutions, and in fact we have uncountably many solutions.